Okay, let's try something here. So this is my summary of data presentation. You'll see on the left-hand side, we've got the techniques, what they're used for, strengths and the weaknesses, and you might want to think also about the alternatives. So at the top, field sketches and photographs, really straightforward. The only thing I'd say about field sketches, of course, the point is you extract what you want when you do a field sketch, and that's why you might still be asked for it in whatever exam you do. Similarly, sketch maps. Sketch maps tend to be, of course, bird's eye view. Field sketches cannot and should not be, bird's eye view. They should be an attempt at 3 dimensions. Good luck with that. Maps of proportional symbols. Remember, you can compound them. So not only might you have a proportional symbol that is, say, pie charts located on a map, but you might, and then obviously, sorry, the radius or the diameter will be proportional to something, but within the pie chart, within the stacked bar chart, whatever it is, and it can be 3 dimensions, of course, and it can be overlaid on a GIS. The key thing, of course, is that you can, I'll show 2 types of data, really good. Flow lines, design lines and trip lines. The only trip here is, of course, that a flow line represents movement, which will have a variable width depending on the frequency. Design lines tend to be straight lines and ignore the topography of the landscape. They are what we call topological maps. You've got the strengths and weaknesses there. Choroplething, really strong, very, very powerful technique, but bear in mind there are weaknesses. The weaknesses on the right hand side are quite obvious, but one to look out for is something called the edge effect, where if you've got, say, 4 different shades of the data, you might have a bright green next to, say, a light green. So that means that on the edge, 1 foot could be dark green showing one colour, 1 foot could be light green showing the other colour. Because, of course, the whole of that region, whatever your study areas, or how it's divided, is given that colour. So quite obvious, you can read these in your own time. You'll notice I'm using my own slideshare here to be able to work through. Second page, isolines. Isoline, many different types, but of course an isoline just is a line that joins up points of equal data. So you can have isoheights, as it says there, for rainfall, isohells for sunshine, isotherms for temperature, and of course contours for height above sea level. Very good, very powerful, shows trends, shows variation. Of course, within this, you're slightly better than the choropleth because you haven't got grouped data. You've got actual locations of the data. It does, of course, require some interpolation. If you don't have every single number ending in 10, say, and you're joining up all your dots, you may have to guesstimate a bit. But as the purpose of all data presentation is to show trends and patterns and anomalies, that's not such a powerful letdown. Dot maps, that's where a single dot is used to show an actual representation of where things occur. Really powerful, unlike choropleth, to show intra sort of regional frequencies. Lots of strengths, and you can see the visual representation is very, very strong. The weakness is sometimes if you've got too many dots merging together, you lose the fidelity of information. But if you're putting a dot map onto a GIS, of course, you can always zoom in to look at those clusters. Remember, whenever you're looking at these maps and you're asked to describe them, you're always looking for maximums, minimums, any trends, and then the anomalies, and you always quote where they are and what they are. Line graphs are pretty straightforward. Just make sure you understand the difference and the power of the line graph versus the logarithmic graph, the arithmetic graph versus the logarithmic graph. And of course, you can stack them. Remember, if you've got a stacked line graph, if you read the very top of the line, you get the overall values, and then you must remember that any breakdown of lines below, you must make sure that you're not reading the top of the line as being the absolute. You've got to make sure you've got the width of the distance. Look, you know what you're talking about. This is a revision text after all. Bar graphs, I'm not going to say anything about. Scatter graphs, really, really important that you know your scatter graphs, because your scatter graph using paired data is a very, very good way to show a trend, which you will then go and investigate with some statistics, usually Spearman's rank correlation coefficient. But of course, we're looking at relationships, we're not looking at causality. Don't know what that means, or you haven't got a clue, ask your geography teacher, ask a science teacher. Really, really good one to make sure you do learn, because it does link into the next section usually in your exams, which is statistical analysis. Pie charts, again, remember what I said before, you can put a pie chart on a base map, you can put it and make it more powerful. Your pie charts can be 3-dimensional if you like, it doesn't matter. Please don't go a whole hog and talking about Excel and the wonderful, the myriad range of different types of pie charts. A pie chart is a pie chart is a pie chart. Percentage data is obviously a very, very important feature, and of course you can have a proportionality based on the size of the pie chart. Triangular graphs are a very, very specific type of graph, and they're usually dealing with percentages and a breakdown of percentages in thirds. So for example, soil texture is a very good one, percentage of silt, sand and clay particles, and also we use them in human geography and things like development, the primary, secondary, tertiary industry sectors, and you can plot a country over time and see how it moves. And I would recommend that you go and have a look at some of the Gapminder stuff, which really uses that quite powerfully. But you can of course represent each country at a time and be able to look at clusters. Do LICs appear in one place? Do HRCs appear in another corner of your triangular graph? Kite diagrams really only ever used in looking at the frequency distribution of species in biogeography, your classic sand dunes, where at the front, at the foredune, you're going to find some really halophytic plants, such as your marron grass, and then gradually that tapers down, and then you get the frequency of something else coming on. They're a kind of sophisticated way of showing line graphs compounded on an axis to give you very, very strong visual representation. Then you get to radial diagrams, and radial diagrams use a circle. So we go 0 round to 360 degrees, which of course for a compass is very obvious. So if you've got to measure the long axis of debris in an ex-glaciated landscape, and you plot them as a frequency, 0 in the middle, the further out of you from your circle you go, the numbers get bigger, join the dots, and you'll be able to see a modality, a modal, a most common set of orientations, which may help to tell you something about which way the ice moved in its last advance or retreat. Logarithmic graphs I've mentioned before, and I should have put it next to line graphs, really powerful when you've got a wide data range. One of the problems is that people find it tricky to analyse them because of the compression at the top of each segment of the way they're constructed. Dispersion graphs, we're not interested, if you like, in the x-axis now, we're interested in plotting on a y-axis and being able to look at where or not there's clustering in a data set. Really quite useful if you want a graphing technique that links into Mann and Whitney's U-test, because that often is trying to look for a clustering within a data set, typically, for example, where you've, say, measured discharge of a glacial meltwater stream at 2 different times of the day or 2 different times of the year, and you'll be able to see that although you can plot the QMEX, you're actually going to see a variation. And that's about it. Those are your classic graphs. You can see there's no more to add. I hope that's a little bit of use.